Okay, welcome to EECS4302, Compilers and Interpreters. And this is my second time teaching the course. Last time was winter 2020. Of course, it was only 0.5 time. It was actually in person, 0.5. The second half was actually remote. I believe quite a good number of you may have taken a course from me before, maybe at least the virtual delivery. If you took a course with me before, welcome back. If no, then it's good to meet you. So my plan today would be I want to walk you through the course syllabus so you will know exactly how we're going to run the course in the coming 13 weeks, well, including the reading week. There will be some little assignment you got to do as well. That's why I say 13. And then I'm going to answer any administrative questions you might have, and then make sure everything is clear. Any remaining time we might have, I'm going to cover some new material, especially I want to give you some overview about what we're going to learn in this course. There will be quite many terminologies you want to get used to, but we're going to introduce to you the first time today, but we're going to definitely repetition will be needed for later. Okay, for me, I just prefer to be called Jackie. I'm quite informal. So, but if you really want to call me Professor, Professor Jackie, Professor Wong, that's okay, right? I'm quite informal, so feel free. And if you need any advice on the course throughout the semester, but I think it's more like a fourth year course, so you're pretty much used to how learning should be done at a university level. So you should be okay, but if you need any advice, please let me know. And if there's any way you think I can do a little bit extra to help your learning, or maybe I should really change the way I teach, I'm more than happy to listen to. All right. Anyway, so if you have not enrolled in the course yet, make sure you send me your name, student number, passport, your ID, so I can enroll you in the course. But for any assigned items we have today or throughout this, in the coming weeks, you have to keep up. No excuse, please. No extension. About the mask, I think the university does not require. Let me just go very quickly. If you want to wear, please wear. If you decide not to, just try to minimize talking and food and drink. Minimize, then we are okay. I think have a very good atmosphere now over here. Okay. Class protocol, try to minimize the usage of mobile phone and talking, and then, okay, just about the slides. So in general, my slides, which I usually try to make available before the class, you can feel free to download them, but I would suggest don't print them out just yet, because usually there might be some typos which identify in the class. I'll fix them after the class. So maybe whenever a slide is really ready for printing, I'll make it explicit on the study site so you can print them out. Let's save some paper. But usually the slides are very much self-contained. You don't need to, if you don't really need to read a textbook, you can just study my slides and just make sure you understand the concept. Of course, if you're always welcome to read extra if you want to get more ideas. But the slides are self-contained, so I don't really read them off that often, sometimes. So I might just focus more on the examples and also to illustrate, make sure you understand. I think that may be better use of your time since you bothered to come, which is good. All right, and ask questions. I definitely don't mind at all to be interrupted anytime. Okay. Writing email to me, I'm sure you guys know. I'm very informal. Just make sure some basic courtesy will be absolutely good. Okay, course information. So there is a single eClass site. I'm pretty sure you guys received some announcement from me yesterday. So that'll be the eClass site. I am not going to use that site that often, except I'm going to use that for sending announcement. And also, I'm going to post the instruction for assignments and also your end of semester project. So these are the only two things. Well, the main two things. There might be something else. You want to check your emails regularly, please. At least once, maybe every day, once every day. And this will be the second site I would suggest you check maybe more than one time per day. Because whenever there's any new study item I make available to you, I'll post them there. It's public domain. You don't, even after they're beyond the course, you can still access them. Okay. And I believe my internet is working, so let me just go there right away. And then I can show you a little bit about what you can see. Sorry, it's going to possibly take some time for Firefox to load. There we go. Okay, so that's the slide. Oh, I should make it bigger, right? So guys, just for your information, I kind of look at the classroom over the weekend. I don't think this might be the best room for us, given that we got 33 people in theory. I already requested the department to change the room. Hopefully they will give us a better option, but I'll keep you posted. I already did it, okay? But just please bear with what we have today. All right, so let me just go over with you very quickly. So that's the site. Just go to my website, eecs.yahoo.ca, tell the Jackie, and then you can easily find under lectures, okay, 4302. And I'm gonna give more detail. I have two kinds of office hour. Either you prefer still Zoom, you can definitely Zoom with me. Or if you want to come to my office in the Sun building, you're always welcome to, right? It's gonna start next week. And some background study. So this course, we're going to use Java mainly, especially later on when you want to build your own compiler, we're going to require you to program in Java. And the tool we're going to show you, Untitled 4, is also going to be in Java. And for those of you who might have not programmed in Java for a while, maybe, so these are all the resources for you. 1022, 2030, 2011. You took them before. But if you want to refer to anything basic, go there or speak to me. And for the tutorials, I kind of put this tutorial here already. It's called Untitled 4. So this is going to be the main tutorial that I will assign to you during the reading week. That tutorial will be extremely important for, number one, your projects. Number two, your upcoming programming test, which I'll speak about as well. And also, I might also put some relevant question in the quiz or maybe in the exam. But I put the link over here, but don't stress over. You don't need to follow them right now. But for those of you who may want to look ahead, you can feel free. But I'm only going to assign that tutorial to you during the reading week. So you got enough time to digest. Okay. And I guess many of you already have been using GitHub, maybe since your first year. So this may not be any issue. But if in case you have never used a GitHub, I will highly recommend try to check in your software in the GitHub. It's a very good way to actually maintain your software. If you got any trouble setting it up, follow the tutorial or talk to me. Okay. All right, under lectures over here, we got syllabus, which I'll go over with you line by line, and also the slides, which I'm presenting now. The schedule, the calendar, we'll look at them as well. And each week is, each class actually, there's gonna be a single row here. And there will be a link to the YouTube recording. I try to record every lecture, but I really hope that technology wouldn't fail on me. In case it fell, there wouldn't be any recording, but I don't think that's likely. So in case you really have to miss a class, don't stress over. You should be able to catch up with the class. That's my intention. And also the notes and slides and also diagram, etc. Okay, that's what we have for this week. Any question about the study side over here? I just want to make sure everybody's kind of clear. Okay. Alrighty, let's now go back to the slides over here. Course syllabus, okay. Yeah, let's now go over the course syllabus together. So what I would do is I'm going to switch to my iPad over here. But then I don't want this icon to be present. There we go. Okay. And let me go to syllabus over here. Let me make it bigger. Just make sure it's readable. Okay, let's go over information. Oh, by the way, so the last time I updated the syllabus was today. But university allowed me to change the grading scheme until September 20th. I don't think that's likely. If I do any information that's inconsistent with today, I will let you know explicitly. So you can kind of assume whatever we talk about today is going to be fixed in stone. All right, course policy. Number one, there will be 3 assignments similar to the labs that you did in the first year. Okay. So I'm experimenting this new policy this year, also with my students in 2030. There will be 3 assignments, 3% each. There will be programming assignment in Java. And here is what you can assume. As long as you make your submission by the deadline, you get a 3% automatically. That's number one. Okay, but if you got a question, I'll take it. Okay, number 2, after we have received your submission, we'll still grade it properly so that you still get proper feedback. So what does this mean? That means you can rest assured you're not going to lose any marks from the programming assignment. You will always get it. However, you can actually reach out to your classmates, to the TA, to myself, maybe to talk about very detailed about how things may be done. So that's really better for your learning at an early stage. That's my intention. Okay? And let me see if there's anything else I should mention. And of course, you want to make sure you meet the deadline. Okay? And then be advised that the later scheduled programming test may be based on, here when I say labs, I mean the assignments. It's possible. So I would say for every programming assignment, still do it before the deadline. I will also, maybe in the class, or maybe some separate tutorial video, I'll walk you over some potential solution. So I'll make sure you know how to do it. Or you can also speak to me about the assignments. Any confusion about it? Yes? 3%, yes, yes. So let me be a little bit more specific. Let's say you submit assignment number 1. Maybe somehow it's not exactly your best effort, but at least you submitted something. Let's say when you get back the feedback for assignment 1, it says that you got 70 marks out of 100. That doesn't really mean you get 70 marks for the final grade for the assignment. You still get a 3%. 70 mark is to say if it was a programming test, you would have got 70%. So that's also giving you some feedback.
So you're getting feedback, but you're automatically getting like that.
Exactly.
As long as it's
Yeah. So thinking another way, it's more like a participation mark, right? Okay, good. Okay, but there will be a single programming test. I'm going to talk about it. And that one there, of course, is going to be individual work. And of course, oh, sorry. This one will be, let me go back to iPad here. Yeah, and then for plagiarism, so that means for the assignment, you don't need to worry about violating the policy of plagiarism. You can reach out to any help you like, including myself. Okay, but of course, for me, I wouldn't give you the solution directly. I might just try to lead you a little bit more explicitly. Okay, and then yeah, so please make sure in order to get a 3%, you must make sure the deadlines are well respected. If late, no, you wouldn't get it, right? Okay, let's see this. Okay, for me, office hour. Okay, we're already Thursday now, so it's already passed. But let me tell you, starting from next week, in-person office hour, it will be from 12:30 to 1:30, Tuesday, Thursday. So my room will be Lausanne 2043. Or if you want to speak to me just online, from your home, from anywhere, it will be 4 to 5 p.m., Monday and Wednesday. Okay. If you want extra time from me, email me. We can arrange that. Not a problem. Okay, the venue over here, but as I said, I already requested for a room change. Hopefully it can be granted. We'll see. Okay. eClass, study material over here, this site. And I already talked about the resources I gave to you. Oh, there's a little typo. It should be 1022, but that doesn't matter. And for those of you who may want to read some textbook, or maybe along the halfway, you find that you're really into the subject of the compiler, which is a very big one. We're not going to cover every single detail of compiler. I want to just give you the technique so you can do something useful. If you really find yourself wanting to dig deeper into the subject of compiler, so these 2 textbooks are rather nice. If you're interested, I'll leave that to you. And for your information, usually on the slide header, I will mention like a EAC. That's this textbook over here, Engineering a Compiler. I kind of base my slides on this textbook. Of course, I also add in many more insights from my end. Okay. And this textbook over here is actually quite a classic one. It's called the Dragon Book. You will see if you actually get a physical copy of that, why it's called Dragon Book. You'll see. All right, anyway. If you got any questions about reading through the textbook, you can also feel free to contact with me, and I'll be more than happy to answer. Okay, I think it would be important to assume, of course, all of you have taken 2001 and 2011. Okay, but I can see here there's no 3311 software design. I wonder how many of you have already taken 3311. Oh, how about not? Sorry, not. That's okay. I wouldn't assume that. I think. How about this? I think this kind of this course, maybe ultimately, we might require 3311 to be taken beforehand. But for now, no, I'm not going to assume that. I think there will be some software design principle that we need to practice, especially when you do the project. But I'll make sure I go over them with you as we go, so you don't need to worry. Especially, we're going to review or maybe learn 2 design patterns, composite and visitor. All right, so these 2. They will be very useful for your project and for one of your assignments. Course description, CIO over here. I don't think we should worry about them now because it wouldn't make sense. We'll see along the way. But for the CIO, you can see that it's kind of suggests the order of covering the topics as we'll see. Okay, grading scheme. Okay, so as I said before, 3 assignments. As long as you submit in time, 9% automatic, no question asked. In the extreme case, if you simply submit the starter code I gave to you as the solution, you still get 3%. But what's the point? Right? It's not very good for your learning. But if you really decide to do that, I respect your choice. But please, try to be more responsible for your learning. For the ultimate project, it's going to be 18% in total. However, I think my experience showed to me, it might be nice not to have only a single submission for the project that counts for 18%. That might be too much. So I think what I will do instead, I'll try to make it at least 2 to 3 milestones for the projects. And for the first and second one, they're mainly to give you some feedback and to push you a bit. But those wouldn't count that much. I'll leave the more important ones, given that you already actually addressed my feedback from the milestone 1 and 2. In the final submission, hopefully that will improve, so you wouldn't lose so many marks. That's my hope. Right? I'll talk more about it, but in total, it's 18%. There will be a single programming test over here, and I'll definitely give you more information later. But that one there, I'll talk a little bit later. We have to gather you into the prison lab in the Sun building, and then you have to do some program independently for about 18 minutes or so, like a one single lab session. Okay, but I'll talk about it. And we got 5 in-class quizzes. Okay, paper test, no multiple choice, no eClass. Okay, just more like a written questions. Maybe I haven't decided yet, but I think 4% each for sure. But maybe each one of them for sure is going to make sure you actually study steadily about what we have covered so far. And I would imagine each one of them will take between 20 to 30 minutes in the first part of the course, the class. But of course, I can give some buffer. Maybe we can start at 2:35 or 2:30. Oh, we'll see. Okay, but I'll give you more information before the first quiz comes. And there will be an in-person exam, and that one there could be just a combination of the multiple choice and also written question, maybe mainly written questions. And that one's going to be 45%. Very heavy because we're going to synthesize everything we have covered in the course, and then that's going to test your knowledge on compiler. So I would say, what's the best way to, so the timing of asking me what should be the best way to prepare the final exam is not about at the end of the semester, it's right now. I can tell you right away. The best way to get prepared is pay attention to all the details from day one. Okay. Anyway, well, if you want to speak more, let's speak in my office hour. And once we calculate your marks, it's going to be just a weighted sum, just very standard way of calculation. There should be no surprise over here. But I'm introducing another bonus mechanism this semester. I'll talk about it by attending classes. Okay, I'll talk about it. Just bear with me. Okay, what about expected weekly workload? It's a standard 3-credit course. So according to Lausanne, it will be between 9 to 13.5 hours of work weekly. Sometimes you might need more. Sometimes you might need less. Okay, depends. Just on average. Definitely about 3 hours for the weekly lecture. And then if you want to attend my office hour, you can count it as well. And then I think I will also ask, we also got one TA for this course. And I'm going to ask her maybe to also schedule some office hour. I can do some survey on the eClass to see which time you guys might prefer. We'll do that a little bit later. For now, it's not that urgent. And then complete the assignment, study for lecture, test, and etc. That should be between 6 to 10.5, around that range. All right. Okay, what about attendance? Oh, before I talk about it, do you guys have any questions so far? Anything you may want me to clarify? Okay, about attendance. Okay, I want to make it short because you can definitely read the details a little bit later yourself. So I think next week, next Monday, I got confused. Next Tuesday and Thursday in class, we're going to maybe experiment how you may have the attendance check. You will need to download something called iClicker. And don't worry about it, I already included one link in the syllabus that's actually a starter guide. Very easy to follow. You need to register for an account, and you also need to make sure you actually supply your student number when you apply for the account. So when we take your attendance check, we can verify you more easily. Okay, so the formula which I'm going to follow would be something like this. Ultimately, I don't necessarily have to check attendance for every class, not necessarily. So, but I'm going to check in between 12 to 23 classes. Okay? And ultimately, if you attend 50% or more, well, if you get 50% or more, you actually got 0.5 bonus to your final grade. And go extra, etc. And then if you actually attend 90% or more, you get 5% bonus. That's a single letter grade, just to let you know. But I thought about whether I should really include this 5% as part of the grading scheme. Maybe not a good idea. I don't want to really penalize you when you miss a class. So I would say, how about try to encourage you to come? I think it will be worth your time. Okay, think about it. And here are simply just some examples about how things may be calculated. I'll leave that to you. I don't want to make you bored. Okay. And then by the way, so this is how you can search for the course. You gotta enroll in that course on the iClicker and then just get ready. So I would say for next Tuesday and Thursday, at least, especially for Tuesday, let's try to see how we can take attendance. Okay, next, I'll remind you on the eClass, but you should just download the app first. Okay, let's talk about the semester calendar here. Okay, let me go there. Over here. Okay. I kind of number each lecture over here, starting from 1. Ultimately, we're going to get to 24. Just make it easy. Okay? You can also easily see what the coverage is for each quiz. The first quiz is going to be on Tuesday, 27th of September, about 3 weeks later. Okay? So today we are in lecture number 1. We might cover something, but you just remember, for example, for quiz number 1, it's going to cover whatever that's before over here. 1, 2, 3, 4, 5. And what about quiz number 2? In principle, it's going to cover 6, 7, 8, and 9. So it's not going to be cumulative. If I need to cover anything, for example, from the previous quiz, I'll let you know explicitly. Okay? So you don't necessarily have to study everything over again. You will do that for the exam anyway. Okay? So we got 5 quizzes. So I would say starting from quiz number 1, you can expect maybe every 2 weeks or so, we got a quiz. Okay? 1, 2, 3, 4, 5. And then other than that, also starting from week number 3, we're going to give you the assignment. We got A1, A2, and also A3. Okay? So let me tell you this. So here, the reading week is very critical. I will emphasize that again later. For this reading week, I'm going to assign to you to study the Antler 4 tutorial video. It's really important for you to really get it understood and also reproduce it on your machine. It's going to be very important for once the project is released. Oh, I'll fix this. That should be the release date for the projects. So about 1 week after the reading week, we're going to release your projects. And your assignment number 3 is also going to depend on that particular tutorial video. And what's more, the programming test that's going to happen is also going to depend on the Antler 4 tutorial. Okay? Now, for the programming test, that's something I'm more open to actually change it. Let me tell you why I put it here to begin with. Even though it's a relatively small class, but to really find a common day that's going to work for all the 33 students, it's kind of challenging. I'm pretty sure if I choose a day on a weekday, there's going to be some of you that may not be able to make it. So why don't I choose, let's say, a Saturday? Only one. On a Saturday, what time? I have no preference. I can do a survey to see which time you guys might prefer. If it turns out you guys really prefer 9 p.m. to 10:30, I'm happy to come. If you want to come between 6 a.m. to 7:30, I'm also willing to come. For that part, I'll leave that to you. So guys, I know it's not very pleasant to really come here for a programming test, but I promise only one, just only one. If you guys prefer a Sunday, I don't mind. Or you think Saturday might be better? How about this? This is what I will do. I'll set up some eClass survey as soon as I can. I'll give you guys some time to think about. I'm going to include all the possible time on that Saturday and Sunday. And then we definitely have to see which one can actually work for everybody. Okay, we need to find that time. And then I'll fix it as soon as I can. And then you may just have to make some arrangement. You may already got some commitment on that day. I apologize, you will have to move it. Okay, please. Okay, I'll do that. But we need to have that programming test. Okay. Any questions so far? Okay. I thought there might be lots of resistance from that. That's good. Awesome. You guys are good. Thank you. Okay. You would prefer a Sunday or a Saturday?
I would prefer Saturday.
Okay, okay. Yeah, sure. Yeah. Good. Anyway, you know what? Interestingly, when I was an undergrad student at York, when I studied, it's not called 1022 back then, it's called 1020. When I had a midterm, it's always on a Sunday because we got about 10 different sections around that time. So they have to spread us out, into different lecture hall on a Sunday simultaneously. That's what happened before. Anyway, they don't do that anymore, which is a good thing, I really hate it. But guys, I really appreciate that you understand. I'll set this up, the survey, and then please let me know, okay? And then we'll sort it out. Okay, so that's about the programming test. And then, okay, about the project, okay? I think once we get to the project point, I'll try to discuss different maybe hints or different details as we go, even in class. I think project is really the best opportunity for you to really see how far you can really reach. I'm still finalizing exactly what's to be done, but I want to find something that's interesting for you to do. But at the same time, you can start making friends in the class. I don't think doing a compiler project, I don't think it's a good idea to have only individual work. That's not a good idea. I would say at least 2, at least. Okay, so I would say, don't feel any pressure. I know, it's hard to be sociable again, right? But anyway, so try to make some friends and then think about who might be your teammates for the project. Think about it, right? You don't need to decide until around this point, the project. And then you will get 1, 2, 3, 4, 5, 6 weeks to do the project. It's going to be a big one. And for the project, I can give you a little bit look ahead. Not only that, you have to implement it in Java, and you have to write some documentation. It's going to be a big compiler, and the documentation will contain 2 things. Number 1, for external user of your compiler, how should they use it? Right, like a user manual. Number 2, for collaborator who's implementer, like a programmer, how are they supposed to extend your compiler and then do the work? Right, so you can see that these are 2 different angles. One is from the external user's point of view. The other one is from the implementer's point of view. You should know both. Okay? We'll talk more about the project. And also for the exam, it's going to be in person sometime between December 8th and 23rd. Of course, we will hope it can be maybe slightly, at least in the middle or the end, so you got more time to study, but we'll see. I already submitted the exam request. It's going to be, in this exam period, it's going to be 3 hours for the exam. Okay, just get prepared. That's about the calendar, I believe. I think everything should be straightforward. Anything you want me to clarify about the calendar, please? Yes? That's a good question. And as we will actually go over today about overview compilation, the answer is no. You are going to design your own input language. Of course, the language can borrow some feature from your favorite language. For example, Java, Python, C#, C++, IFO. I'm not sure how many of you actually used IFO before in 3311. Yeah, I know. It's then I'm pretty sure you were my student before. But anyway, no. But for this semester, don't worry. We are not touching IFO. In case you're worried. Yeah. Yes. Okay, good for you. Don't worry. I think, okay, let me just say a little bit more. In industry, what I heard from my past students, when they were asked to build a compiler, they don't necessarily have to build a compiler of Java to say you want to translate Java into something else. Instead, they have some very special syntax that's only used internally that they have to get used to. So that's something I want you to experience as well. Design your own language. Borrow all the exciting features you would like to support. Maybe you want a hybrid language that will have all the capacities in that. Of course, that will make your job harder as well. But anyway, I think for the project, when we evaluate it, we want to see how rich your language is and how versatile the functionalities it has. That's something to mention later. There was a question here, right? Yes? What platform? You mean like a Windows or Mac, right? Is that what you're talking about? I can tell you that It doesn't really matter. It should really be cross-platform. But when we evaluate your work, I think we're going to evaluate it on the EECS Linux server. That's what we're going to do.
So we're targeting like x86 Linux.
Yeah, something like that. But I think since the compiler tool itself is actually in Java, so I think it should be cross-platform. It should not be an issue.
And the compiler can be cross-platform, but like the output.
The output is something. Well, for the output, we'll talk a little bit later. The output for yeah, I know what you mean. If the output happen to be C, in that case, of course, you want to make sure the C program can be executable on our Linux server. Okay, everything is going to be evaluated on the Linux server for the EECS department. Yeah. Question somewhere? All right. Yeah, and actually for you guys, actually this will be something to your advantage. I'm not reusing the project that I did in winter 2020 because student complained it was too hard. So I decided, I'm not trying to make it too much easier. That would be not good. I still make it reasonably challenging because it's a project, right? However, I try to make it slightly more interesting. Okay, anyway. But maybe at the end of the semester, I can tell you what your classmate did last winter. So you will maybe appreciate what you're doing this semester. We'll see. Okay, yeah. Alrighty. Okay, that's about the calendar, right? And of course, if you got any doubts about what I say today, just get in touch with me. I'll be more than happy to answer. Okay, so that's about, and I think one more thing I want to say over here about the schedule. Yeah, this one just summarizes what's going to happen for this course, right? You got the 2 Tuesday, Thursday classes, and also Zoom office hour, and also the in-person office hour. Hopefully, I can also add 2 slots more, maybe about TA office hour. We'll see. For now, it's not that needed, just for now. All right? Let me now go back to syllabus to see what else to say. Calendar and the coverage, right? I already talked about the coverage. So here, the programming test says it's going to cover all the assignments and Antelope 4. It's like everything. So don't panic too much. I think mainly it's going to be Antelope 4 and assignment number 3. But I put assignment 1 and 2 just in case. But I'll let you know at least 1 week beforehand what's going to be covered, so you can be more focused. And weekly schedule is already talked about. Okay. And just about the topics that we're going to cover, I think we're doing pretty well in time. And I usually, since it's the first class, I like to just give everybody some little bit of relief. We are not going to go all the way until 2:50. I can finish about 10 minutes earlier today, okay, just to give you some break time. But so that means I'm going to cover about maybe 30 minutes or so, only today. And then whatever that's not done, I'm going to do that on Tuesday. Beg your pardon. Okay, let me just talk about very briefly. That'll be the last part for the syllabus. We'll start with about different terminology about compilation, and then we're going to talk about lexical analysis, syntactical analysis, and bear in mind, I'm going to repeat this over and over. We have to learn this theoretical foundation so that we can appreciate when you do your projects, you do not have to implement the lexical and syntactical analysis by your hands. You don't have to. There is something so-called parser generator, Antelope 4. That is going to generate everything for you. And let me ask you this. Back in 2001, what kind of stuff do you specify in order to define the rules for a language? Yes? Formal language is the language itself, right? But what about, I want to say, let me give you some hints. Regular expression is one kind. It's more like a lexical level, regular expression, because that tells you about character followed by each character, right? But what about you got individual words? You want to worry about how to put them in a meaningful way. Yes? Can you be a little bit more complete? What do you mean grammar? Context-free, context-sensitive, or whatever? Context-free grammar. And I'm pretty sure you guys might have the confusion that what is it called context-free? What does it really mean when I say context not free or context sensitive? That's something that will be answered in this course as well. Okay, there's a reason for the term, but you're right, context-free grammar. Okay, so we're gonna review basically what you learned in 2001. I think that's also very important to know the theoretical foundation, and we'll make sure we have covered those topics in the quizzes as well. So these are the two things. We're definitely going to spend a little bit more time. I think definitely more time on the parser than the scanner. Okay, because for parser, of course, the context-free grammar part is something you learned from 2001, but there are certain stuff which you didn't learn that'll be new. For example, if you want to do parsing, for example, you got some string, you want to somehow parse it into a parse tree. How can you do it algorithmically? So there are two ways, either top-down or bottom-up. So these are the two things we're going to discuss in this course. So later on, in theory, if you really want to implement your own parser, you can do it. Actually, in one of the assignments, you have to implement a parser. Okay, but don't forget, you get that 3% right away, right? But you have to make sure, spend enough time to learn it. That's a good thing. Okay, and then we got use of a parser generator. Okay, you will see this term very often called parser generator. I will try to maybe revisit this term a little bit later once we reach that point. But just remember, the parser generator antler here we are using is only a tool for Java. For any mainstream programming language you want to use, they should have a parser generator. For example, let's say you're now doing a new project for your supervisor at work, let's say for Python. You want to define some very special thing, maybe a core subset of the Python. You want to design some compiler for that. In that way, what you really want to search or Google for is the parser generator for Python, or parser generator for language X. That's basically the principle you want to bear in mind. Okay? But for this course, we do the parser generator for Java. Okay. And then we're going to review or introduce OOP design patterns, composite and visitor specifically. And also, time permitted, I think I should at least cover some of these, which I didn't get a chance to cover last time in the during the lock. But I think you guys do deserve to know some details about this part here. Okay, I will definitely cover that, maybe in the final few weeks. Okay, that's about the syllabus. Let me just go back to the slides. And for the quizzes, I think, yep, so if you really had to miss a quiz, please give me some documentation, like before the pandemic. And then, yep, so if it's a valid excuse, I would be more than happy to shift the weights to the exam. Okay. And study tips. Yeah, just make sure you don't really stop coming to class just because there's a recording, right? They should not be a replacement. It's mainly for you try to really concentrate completely in the class to get as much comprehension as possible, and then whatever gap you need to fill out you can watch the recording. That'll be the plan. All right. Anyway, you can refer to that. And then I think yeah, for this course, since we're going to cover sometimes quite complicated algorithm, especially top-down or bottom-up parsing. So I think stay on top of how things are working that way and be curious. That'll be the best way to succeed. I think this course itself is very much fun. And for historical remark, do you know how many times this course has been taught in the past 20 years? Let's say excluding this time. 3, right? 2. The first time it was the first time it was taught 2006. Second time 2020. In 2006, I was in that class as a student. 2020, I was in that class as an instructor. That's amazing. Anyway, so my point is somehow the department is not really treating this course with much importance, but I think this course is a must for any CS graduate. So I'm really glad you guys made the right choice to study this course. You will definitely learn something, for sure. That's my guarantee. Okay, hopefully you get good grade as well. I know that's also important, for sure. Absolutely. Absolutely. One more thing to mention to you guys. Have you guys been wondering about why sometimes professors will have to make their final maybe more difficult if there are too many A's or A pluses before the exam? Do you guys know? There's some rule. I think there's some rule there. I forgot the magic number, maybe 25. If a class has more than 25 students, in that way, we cannot have more than 30% A or A plus. We cannot have more than 30% E or F. If you do, either you have to justify, or you have to do some adjustment, or for example, building the curve, right? But currently, you see we are 33, so too bad, we are subject to that rule. If somehow we get to May 25, 24, maybe we are fine. We'll see, right? But hopefully everybody will stay. I just want to give you some information here. All right. Anything else? Okay, one final slide before I get to the actual contest. If you do need any accommodation about the quiz, and I think for the assignment, since it's participation mark only, so we don't need any extension for you. But I think for the project, it's going to be teamwork, so just make sure you start in time. So I don't think there's any extension either. So the only thing I think you will need definitely will be the in-class quizzes and also the exam. So please let me know early in advance, so I will try to see how I can arrange it, okay, for the accommodation. Let me know. All right, guys, any questions before I start covering the subjects for about, I promise around 40, right? So I would say about 25 minutes. We can cover some useful stuff for sure. Any questions before I start? Awesome. Let's now get started. Okay. There's one thing I'm curious about. Do you guys prefer some kind of like a 5 minute, like a 2 or 3 minutes break in the middle? Do you like it? Or you'd rather for me to go all the way until like 3:50? Do you Okay, how about 2 or 3 minutes? Okay. Why don't you guys now, oh, don't go away. Okay, just stretch your leg, and then I'm gonna set up the slides, just 2 minutes. Okay, and then we'll start again. Okay, 1 more minute, and then we'll get started. Okay.
Unless you're making malware. Oh yeah, yeah. You have your really innocent looking program, and then it rewrites itself as malware and then runs itself.
Yeah. They're called, I can't remember the term. There's some word for it, but it rewrites itself for to make the hide from detection.
Interesting.
Yeah.
All you need is
rewrites to
yeah.
All right, shall we get started again? All right. Yeah, so we'll do this 2 minutes to 3 minutes break, maybe every time. So I think it's good for both you and me. So I can also catch a breath as well. All right, so today, part of Tuesday, I would like to talk about just the overview of the compilation. I want to go over some terminology with you, many of them. And also I'm going to give you some example compiler. I think I got 2, right? Hopefully we can at least get to the first one, but second one for sure, we can talk about it briefly. It could have some linkage to your project. You can get a flavor about what you might be able to achieve. Okay, let's talk about it. Okay. What is a compiler? A very short definition. It is a software system, meaning that you got to write some code to implement it. And as soon as you have to write a lot of code, it should be subject to good software engineering principles, which you learn in 3311. But since we cannot assume you actually took that course before, we're going to walk you through all the principles. But for today, I'll just talk briefly about them. I'll give you more details later. At least you know the terms exist. Automatically, so once you implement a compiler, it's going to be input in, output out. Whatever that's happening inside is magic. Only the developer will know. It's going to translate or transform, well, obviously, from input to output. However, let's be careful with the language here. I say input written in one language, output written in another language, meaning that input and output could be the same. For example, Java to Java, could be different. Java to C, Java to C++, Java to SQL, for example, right? So it's a very general tool that you can build. Of course, what you have to know how to build will be the magic that's inside the box. We'll talk about it. So this is this is one diagram I would like to go over with you in detail. It's really important to have a conceptual map in your head about what how the compiler works. Okay, let's switch there. I want you to stare at this diagram yourself just for about 30 seconds, and then I'll go over them with you. Just 30 seconds to see what's there. Of course, I'll explain the arrow as well later, but just for now, I'll give you 30 seconds. Okay, a little bit longer. Awesome. Okay, you can see many boxes over here and also many even shaded box over there, you know, of different shape. There's a reason for that. Okay, let's go over them. Let me start with, over here, I want to start with this word over here. Semantic domain. Semantic domain. It's really important for you to understand what semantics really is. What the synonym to semantics is just meaning. What's the meaning of your language? And a very typical example for input could be, for example, let's say the input can just be maybe Java. In that case, the semantic domain will just be object-oriented, right? Just another way, one example for output over here, let's say you're kind of because serializing your object-oriented programming into some maybe database queries, or you want to persist the data. So in this case, one example could be, let's say, SQL. For those of you who took a database course before, now you will see, but we wouldn't assume it. Okay, so this apparently is a different semantic domain. What would be that domain? Definitely it's not OO. What is that? What's the theoretical foundation for SQL database? I'm looking for one keyword. Or, let me ask you this. When you took that, or for those of you who took a database course before, before you learn about the syntax of SQL, you learn about something calculus, something algebra. What's that something? Not linear, no. Relational model. So relational model is the theoretical framework for SQL queries to work. Relational. Everything is relational in your SQL database. Okay? And think about SQL itself is just the syntax of your relational algebra. Okay? Think about the points over here. Might be very new to you, but it's really sensible. Okay, I'll put it here, relational. Okay, relational, that's semantic domain. And semantic domain could be different, could be the same. Okay, but I'll just give you one example that's not the same. If I go back to the slides, I do have a very short definition for you. Whenever we talk about a semantic domain, it's really a context with its own vocabulary, like a different words or different terminology, and also its meaning. And for your project, ultimately, you will have to define some semantic, you should really define what the semantics is for your input language and also the output language. Otherwise, there's no way for you to implement the magic inside the box. And we'll do some exercise in just a moment. But let me go over a little bit more. Okay. Let's see this. So we got some input program. Okay, usually I like to use green. That's the input, and that is the output, right? For example, you would say my class 1.java. You want to translate it into maybe my class 1.SQL, right? That's one example. And what does it really mean when I have this part over here? Okay, let me just dive a little bit deeper. When I say, let's say my class 1.java, somehow I can generate by the compiler, let's say my class 1.SQL. Of course, I'm here simplifying the matter. It doesn't really mean if there's only a single class as input, you can only get one single file as the output. It could be multiple, right? It doesn't matter. Okay, it's kind of up to your definition. This is, so you can think about from this to this, is only an instance of the translation or compilation. To really implement something that's general enough, meaning that given any arbitrary Java program, you want to translate it into the corresponding SQL queries. You have to somehow define some general rule. So that's what these two are talking about over here, okay? So for now, I'm just going to say this part over here is more like the grammar or rule. Grammar of the input to generalize the input structure. And this part over here is really the output. Okay, so this part over here is really the grammar of the output. And for your compiler over here in the middle, which I'm going to use maybe purple over here, and for your compiler implementation, if you actually want to implement the translation between Java and SQL, you're actually not going to look at this and this example specifically. It could be your initial point just to get some idea, but when you implement the code, you have to see, given the structure of Java, how can I turn that into the corresponding structure in SQL? So that's why I also got these two arrows over here to say you have to have some grammar defined for the input, some grammar defined for the output, and for your compiler, you also have to define the transformation between the two structure. Okay? That's basically what this diagram is trying to say. And you will experience that in your assignment number 3 and your project, for sure. Guys, any part you think I should really explain a little bit more, you're fine. Before we do some little exercise, not just yet, maybe a little bit later. Any question? Everybody's happy? Good. Oh, sorry. Over here. Okay, semantic domain. So just some examples. So for OO, basically what you learn in those Java courses like OO. And also database, and also predicate. There should be no reason that you cannot turn Java into predicates, what you learn in 1090, as long as you know how to translate it. Okay, that's my point. Semantic domain. And there might be different semantic domain. And then this one here, C procedural programs to MISP. I'm pretty sure you guys know MISP, right? Maybe from 2021, maybe a long time ago, the assembly. It's called MISP, am I right? MISP?
We've been learning risk.
Oh, sure, no problem. Yeah, I'll change that. Maybe for next year. But don't worry, it's from C to assembly. I can tell you that this one here is the most typical or the old school application of a compiler to go from programming language into assembly. Okay? When I took the compiler course back in 2006, our project was to translate a subset of C into Pascal. Not even sure if you heard about it, Pascal. It's an old school language as well. Anyway, I think the first example here to go from Java into SQL, that's a more modern application of the compiler. But in your application, even beyond this course, don't restrict yourself. You can basically translate anything to anything else. That's really my take-home message for you. Okay. Okay, so the idea about a compiler is extremely powerful. Extremely powerful. As I said, turn anything into anything else. As long as, so there's some precondition. I'm not saying you can always turn from anything to anything else. There are some precondition over there. What are they? Number one, you should know the syntax for the input and the syntax for the output. Number one, you know the structure, right? So the syntax are basically here and also here. If I only know the structure of these two, would that be enough? Not really. Even I still need to know how to program the magic over here, right? I should know how should I go from one structure to the other, right? So that's about semantics. If I go back here, now these are semantics. So the syntax should be specifiable as a context-free grammar, and the semantics should be programmed like a Java methods to go from one structure in the input domain to the corresponding structure in the output domain, the semantics. So that's it's a very strong statement over here to say the compiler is a very powerful mechanism to really implement something that looks very cool. But we should always know there might be a boundary to what you can implement as a compiler. So what I would like to do is, it's the first class so we can have some fun. I have a mental exercise for everybody. For those of you who took a class with me maybe some time ago, you may have seen this already, but maybe you have already forgotten. That's okay. Let's do this together. I'm going to pose an A+ challenge to everybody on day one. And I'm going to present it in just a moment. The idea would be, if you're able to solve this challenge, you get an A+ right away for the course. Right away. No question asked. A+. You're doing reverse psychology, right? It should not be possible, otherwise Jackie wouldn't say that, right? It turns out, the problem I'm going to describe to you, if you can solve it, you should deserve not just an A+, you deserve a Nobel Prize award. Okay, let's take a look. That's why I want to make it a little bit more dramatic, but I think that's some insight into what you have seen since the first year. You may have thought about it, but you never know why. Let's talk about it quickly. Quick question for you. Remember, let's say go back to your first and second year when you program in Eclipse, right? Have you been wondering about sometimes, of course, Eclipse can highlight certain compilation error, like a red underline, but there are certain things that they wouldn't be able to highlight. For example, so you might run into class cast exception. You might run into maybe some runtime, like a null pointer exception, or maybe array index out of bound exception. Why can those errors not be found at the compilation time? It's a fundamental question there. It's more like a halting problem. Yes, it's undecidable. That's basically what you guys learned in 2001. And I'm going to use something similar right now to illustrate the point, because I want you guys to know, even though compiler is so powerful, there's some boundary. Don't think about you can just implement anything by compiler. You may be just wasting your time. So that means don't try this A+ challenge. It's not going to work. But I'm going to mention that to you. Okay. Let's say this is something you may want to do. Of course, don't do it, right? Just hypothetically. Let's say that's your compiler. Okay, your compiler is going to take two inputs. It would be some Java program and then some variable name. Only two inputs. The output is going to be very easy. We want to figure out, assuming that S is a reference type, not primitive type. We want to know what's the last dynamic type of variable S. That's a compiler you want to build. It sounds simple. Sounds that maybe if I do some sophisticated analysis on my Java program, I should be able to do it, right? Even for simple program like this, for example, what I'm saying is, you can see I got my class over here. I got some main method. I initialize some reference variable. I do something arbitrary in the middle. Eventually, I will assign. S is assigned to a new resident student. So this will be the dynamic type. It seems like. Agree? Do you think it's really that easy? Do you think you can really write such a compiler to figure out the last dynamic type of some given variable? You guys can think about it, but I'm going to tell you the answer right away, just to save the time. It turns out it is an undecidable problem, meaning that there's no program that can solve it. The best you can do is exactly what Eclipse or IntelliJ is doing for you. The best you can do, I'll sketch very quickly. The best strategy is to simulate the program, meaning that to execute the program and see or check the last dynamic type. Basically, I'm going to run, I know pretty well the execution semantics of the program should be from the first line until the last line. I can start from this line, go all the way to here. If I can reach over here, I would know the last dynamic type should be resident students. If I stop maybe a little bit earlier, I can just see what the dynamic type is. Okay. Is this going to work in general? No, because maybe, for example, maybe somewhere, I'm just making one example, let's say somewhere in the dot, 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 we have something like a while, some very complicated Boolean expression over here. And there's no guarantee that this Boolean expression will ultimately turn to false, meaning that you're going to have some infinite loop. If you got infinite loop, your program is not going to terminate, so that the simulator, your compiler, is also not going to terminate, so you will never know. So that's why it's undecidable. I'm presenting in a very informal way. Of course, I'm not trying to prove it, but I want you guys to know. This is kind of the problem you just cannot solve by the compiler. Just know that. On the other hand, there are many other things that are actually exciting that we can do by compiler. Okay. Any insight to share or any follow-up you want to share before I move for this one? All right. Of course, if you're not convinced, you can still try this A+ challenge. My offer stands until I retire. Okay, so anyway, you know what that means. Alrighty. Okay, knowing what the boundary is, let's now talk about the principle. Okay, as I promised, I'm just going to mention the terms to you very quickly today, but we're definitely going to cover them one by one throughout the semester. At least you know the term. For those of you who might be keen to learn about them, feel free to maybe do some little bit of research, Wikipedia, maybe your 3311 textbook, or do your own research and speak to me. But we'll definitely try to cover them. Modularity. Basically, you want to have not just a so-called Superman class for your Java implementation. You want to have multiple classes together, interacting with each other. Back in 2030, you learned about something called aggregation, right? Let me just sketch the idea for you very quickly. So the first principle is about modularity. Let me just take a look at the time. Yeah, about 5 minutes, and I'll end the lecture, since I promised. Modularity. That means you may have multiple classes over here, and then they may have different association in between them, something like that. Okay. Oh, if I ever do this in the class, please shout to me to say you forgot to switch the iPad. There we go. All right, please let me know. Modularity is really about you got multiple classes rather than a single, the so-called Superman class doing everything. If you actually got a single class that has so many lines of code, it's a no-no. It's a warning sign to your design, right? Number one, modularity. I'll speak more about it later. The second one is about information hiding, okay? I think for information hiding, it's a little bit difficult just to sketch conceptually, but I will try to give you some more example later when we get to the project. Information hiding basically is about you have to identify stable part and unstable part of your class. The unstable part should not be made public. Otherwise, any user of that unstable part is going to be upset whenever you change that unstable part. But don't worry, I'm going to elaborate a little bit later with some example. Single choice principle, right? That's something I always mention is a very important one. Single choice principle simply means whenever you want to make a change to your software, it should really cause the minimum number of changes. A very typical example you want to avoid. Let's say you got multiple duplicates of methods in your software in different classes. If you actually somehow want to change that particular method, how many places do you have to change? Multiple places, not just a single one. So that means what you should have done, is to define that method as a helper method. Whenever you want to use it, call the helper method. That's basically the idea, right? Single choice principle. Design patterns, and for design patterns, we're going to review very quickly about polymorphism, dynamic binding, since we talk about Java, right? So these are the two most important features of OOP, right? That's something we also have to review. Finally, regression testing. Do you guys know what regression testing really means? You can put in a simple term. Yes?
Testing to make sure bugs that you had before don't reappear.
Yeah, very good, very good. Okay, let me explain the regression testing very quickly. Okay, just that one. First of all, regression. Let's say you don't necessarily understand regression in the context of software development. What about in reading? You know pretty much what regression really means in reading, right? Let's say I'm reading a single page of text. What does regression really mean? I'm reading line number 1, line number 2, line number 3. I forgot about what I read about line number 1. So I'll go back here and read. Read again, read again, read again, read again. I forgot. So I'll go back here, just keep repeating. That's something considered as bad when you do reading, right? You shouldn't really do that, regression, so many times. However, in the context of software design, regression is good, highly recommended. Why? Thinking this way. Let's say conceptually, if you got your implementation over here, modularity, remember, you got multiple Java classes over here, okay? In parallel to your implementation, you should have a set of JUnit test cases. And what does the JUnit test cases do? They will try to call different methods from your implementation and compare the actual output with the expected output, right? To see if you get a green bar. You guys know about how to use JUnit tests, I'm pretty sure, okay? So that'll be uses. And then this one over here is going to have some actual output, and then you will compare. And as your classmate correctly said, let's say this. Let's say so far I have implemented my classes over here. I run all the JUnit test cases. Everything passed. If I try to make some change over here, or if I try to add some addition, maybe a new method or a new class over here, what I should do for sure, before I can check in my software package into GitHub so that my collaborator can actually work on that, I should be responsible by running all the JUnit test cases again to make sure I still get a green bar. If I get, for example, a red bar, what does that mean? That means the failure must come from the latest change I have made. That's regression testing. You want to make sure you have to maintain a repository of JUnit test cases. Whenever you make a change, you want to do two things. Number one, you may want to expand the number of JUnit test cases. And then you want to make sure you still get a green bar. As soon as you see a red bar, stop developing and then fix the bug first. Okay? That's regression testing, and which you guys must do for the project, for your practice. Okay. Okay, I think as a promise, I think I should really, yeah, just about time. I'm actually 2 minutes late than what I promised. So guys, do you have any question for me? No. Everybody is good? Okay, I'm gonna stop here. And then from next Tuesday, Thursday, we're gonna cover, I'll continue from here, and then we'll move on to lexical analysis. All right, you guys take care, and I'll post the recording later today or tomorrow.